Hello, everyone. Um, this section is 5.3 and 5.4 and 5.5. Um, and as you all know that the exam is coming up this Thursday, right? Which is going to be during the regular class time, which is 5:30 p.m. It's gonna be covering these sections, and I hope you guys have already seen the exam review. I have emailed you guys, or maybe I think I have posted that on the Blackboard as well. So yeah, please do that. Those review problems for exams, um, it will be a really good practice, you know. Um, and like I said, on this exam, I will be focusing probably on few problems where you need to understand the materials. So that's why I keep saying, please watch my whole videos and try to understand it, understand the lecture. Uh, so yeah, but the exam, basically in the exam, I won't be asking just the problems where you just need to compute. I won't be asking those kind of, I will be asking those computational problem as well, but I will also be asking some problems where you need to understand the materials. So please, that's why I've been saying you need to watch the whole videos, you need to understand the materials, all right? And yeah, the web assigned homework of 5.2 and 5.3 is due Wednesday, yeah, which is October 28th, because exam is on Thursday, which is October 29th. And I'm covering the exam till 5.3. So yeah, that's why it's due on Wednesday. Anyway, so this is 5.4 and 5.5. So basically, I'm combining both Monday lecture and Tuesday lecture on this video. So I'll upload this for Monday, but still, I mean, this is also part of Tuesday. So that means you guys won't see any video for Tuesday. And also, since you guys have exam on Thursday, so yeah, I mean, it's I don't think it's a good idea to upload any video on Tuesday. I might do that later on, but at least for right now, yeah, or at least for this week, you won't see any video for Tuesday because this is a part of Tuesday lecture as well. Anyway, so the section I'm covering today is going to be pretty simple uh, because these sections are basically focusing on applications. So it's just that we are seeing how we can apply math in physics. All right, so we are looking some physics techniques. So it's going to be pretty simple. We just need to know few formulas from physics and just going to apply that formula here in math. All right, so but still, I mean, you need to understand how we are applying these things in physics. All right, that's why that's the whole point of this section. Um, okay, anyway, so the first one is the work. All right, so the work, if you go back to physics, the work, we know the formula of work. Work is also force times distance, right? This is something that you probably guys learned this in physics, or if you haven't learned this, not to worry, I'm not going to go too deep into physics. This is a formula. Work is equals to force times distance. So we can also say that we can also say force as capital F and D as distance, so FD. All right. So the unit of this when you compute something later on, this, so the unit of this one is basically called joule, or you can even say just J. All right. Okay, now what is force? So force, I guess you all know that force is mass time gravity, right? So the mass, we can also say the mass M and the gravity G. So mg, force is, or F is equals to mg, or you can even say ma, right? So where G is, well, M is a mass, G is a gravity, and we can, G is, there is a standard value of G, which is 9.8 meter per second square. All right, and the unit of the force, the unit of force is Newton, or simply we can write N. All right, so yeah, that's that. These are the things we need to know from physics. Now we're going to apply these things in math here. So let's look at the problem. So when you okay, so well, this one is okay. There is nothing complicated here, I guess. So how much work is done lifting 2 kg? So 2 kg means okay, m is given, mass is given. Mass is 2 kg, and okay, 2 kg off the floor to put it on a desk that is 5 meter high. So that means 5 meter is high, means the distance, we can say the d is 5 meter. Okay, now we are trying to find the work. All right, so we know that work is force, capital F, sorry, force time distance, right? So we don't know force. Well, the force is not given. Well, we know the distance d is 5. Now, what is force? Force, well, we also know that the force is mg, right? Mg. So that means m is given, which is 2 kg. G, well, we know the standard value of G, which is 9.8, right? That's what I say here, 9.8, and 5, yeah. Now, when you multiply all of these, you'll get 98. And what about the unit here? So the unit, like I said, the work unit is joules, so just write G. Okay. So yeah, so when you have numbers like this, you're trying to find the work done, pretty simple, right? So this probably you guys might do these kind of problems in physics. Now, what about instead of, let's say, okay, now instead of okay, now force here, equation is given, okay, and when a particle is located at a distance x meter, okay, and the force is given this much Newton, and now we need to find the work uh, where x is going to be from 1 to 4. Okay, so the interval is given, equation is given, so we can think, okay, we can probably change this to something to integral, right? So what we are saying here is, well, since we are saying that it's force times a distance, right? So the distance, well, it's from 0 to 1. So, or basically we can even write this, which means change in distance. All right, so this one also we can say technically here, we can also say delta x is also basically, we can even write dx. So this means change in distance or change in x. All right, so when you write this in a mathematical or something that we are learning right now, when you are changing this to that form, then, well, now we can introduce an integral. The force is this, x to the power 3 plus 2x, change or delta x is also basically dx. That's what I said, right? And we're saying that this delta x, or this is also called change in x, right? So change in x, we're saying it's from 1 to 4. So 1 to 4, there you go. So it's pretty simple now, right? So we're finding w work done. There you go. Now find w. So that means we just have to integrate this and we'll get the answer, right? Pretty simple. But yes, it's simple, but someone who doesn't know this idea might be confusing. So that's why I've been saying this section, the whole reason of this section is to see how we can apply math in physics. All right. Okay, so that means here, now just take the integration here. So here it will be x to the power 4 over 4. Here it will be 2x squared over 2. So the interval is from 1 to 4. So that means they used to work on. So now here it will be, so you guys can do that part. All right, so or I can show it, or yeah, let's not do it. Because I think you guys can do it. So the final answer you'll be getting here is going to be 315/4. All right, so the work done is this. Now the unit for the work done is joule, right? So yeah, make sure you guys write that. It's important. You might lose some points if I don't see any unit. All right, so yeah, please make sure you write that at the end if I ask something like this in the exam. Okay, now the next one is this is now so these were 5.4. Now this is 5.5. Okay, so on the 5.5, it is a mean value theorem of integral. So there is a theorem, mean value theorem for integral. So the theorem says that, well, if you have a continuous function, so if let's say there is a function f which is continuous on some interval, oops, interval a to b. All right, and then we can say that there is a number c on a to b. So there is an integral a to b. So then we're saying there is a number, and so there is any number, c just a random number. There can be any number between this interval, any number. C can be anywhere. It's just a c is here. So such that we will get that f of c. So when you plug this into a function of c, this can also be 1 over b minus a. So yeah, b is here, a is here, b minus a times integration. Again, the interval is from a to b of that function in terms of x. Okay, so this is a mean value theorem. Or we can also say that this is also equals to, f average, or average value of a function. All right, this is the average value, f avz. Ave is on the bottom. So these two are basically the same thing. All right, so when you see a problem asking something like this, find the average value of a function on some interval like this. So it's just that you have to use this formula here. Okay, so f average is also 1 over b minus a to b, f of x dx. So here the b is, well, on the interval, the first number is a, the second number is b. So a is 1, b is 2. You could say that from this interval, right? So all right, so we have everything. So it's just that you have to plug this in here and get the answer. Okay, so we have already learned this integration thing, so I don't think it should be that much of a big deal. So now 2 minus a, or b minus 2 minus 1, or b minus a is just 1. A is 1, b is 2, f of x is x plus x squared dx. 1 over 1 is 1, so we don't really have to write that. Just integrate that. All right, so now, well, it's from 1 to 2. So this is same as 2 squared, or 4 over 2. 2 to the power 3 is 8 over 3 minus all right, minus, and we also need to plug this in here, 1/2 plus 1/3. Distribute this minus to these two, combine all of these, and you'll get some answer at the end. All right, so yeah, you guys can do that. It's not a quiz problem. It's not a quiz problem. Just get the answer, and that's the average value. All right, FAVE. All right, so like I said at the beginning of the lecture, that there is nothing complicated here. It's just that there is a formula there which is slightly different, right? It looks different compared to what we are learning, but again, when we start solving this, it's not really complicated. It's just that once you get the values, all right, it's going to be pretty simple. All right, so actually, I don't have a lot of things to talk from this sections based on what you're learning. So yeah, this section I will cover this, or this will be part of exam 4. I'm not going to ask this sections on exam 3. Okay. Yeah, so that's it. That's it from this lecture. I'll see you in the next video. All right, thank you.